Myerson is releasing their full system to create denture digitally, 3D printing. That means we have the tooth resin, which has been out for a while now. We have our denture-based resin and the bonding agent to lute them together. And so it's real exciting. Trusana is a great chemistry, and to have a full system, a full package to be able to produce a denture is really exciting. Let me give you a little background about Myerson, which I think is important. Myerson's been around for over 100 years. And over those 100 years, they've produced essentially all removable materials. And I don't know that there is any other company that's like that. They've started with denture teeth, and over the years, they've gotten into flexible partial materials, sleep appliances, and right now, Myerson is the largest CAD/CAM metal-free flexible partial material that's available. So as Myerson kind of got moving towards the digital side of things, they saw that dental labs were essentially going to become your own tooth manufacturers. And Myerson, being one of the larger tooth manufacturers in the industry, decided not to fight against that, but actually kind of join in to that digital side of our industry to be able to create a material so that dental labs, you guys can create your own teeth. And so Myerson came up with Trusana. They released Trusana over a year ago, over probably a year and a half ago. And because of FDA and a couple of different things, we didn't have a denture base to go with it. But the reason that Trusana was initially developed was for all-on-X applications. So screw-retined, full arch appliances. In our industry, those types of appliances were traditionally done with some sort of a metal substructure and then processing pink acrylic and denture teeth to that. And that system had some of the highest failure rates of really anything that we do in our industry. And that definitely is not something that you can make money at if you're constantly repairing, fixing, and possibly remaking. And so Dr. Stansberry saw that was definitely an issue in our industry and developed a material to satisfy that issue, a very strong 3D printed material. And in developing that for that application, that very harsh application that needs a lot of strength, we realized, well, it's a beautiful material. It's easily produced. It would be a great denture tooth. If it's good being bolted directly to bone in the jaw, so there's no cushion at all, and it lasts and is strong. Well, in a denture application or even a partial application, this would be an excellent material. And so that's kind of why we moved forward from just having a tooth colored resin for the Trusana to the denture base. Now, something that's exciting and kind of scary all at the same time is the fact that dental is one of the largest users of 3D printing in all these different industries, right? You'd think aerospace, you'd think automotive, you'd think that some of those would trump dental, us guys just making teeth and models and stuff, but we're blowing them away. And it's exciting, but also scary. Exciting part of it is that people are developing these machines and materials for our industry. And, in the past, we've had materials and products they wind up getting developed in aerospace or for something else, and somebody goes, hey, that material will probably look pretty good and be strong enough to make a crown out of, or something like that. And it gets kind of adapted to work in industry. But now we're actually getting materials and products that are developed specifically for our industry. And so again, that's cool, right? Because we're getting stuff that's working and the technology is moving fast. But that's also a scary thing because you know, to credit you guys, you're sitting in on these presentations and you're educating yourselves to try to keep up with the latest in machinery as well as materials that you'll see today. And so with all that advancement in technology, we need it. The mouth is a harsh place. And so what we need is exactly this, a material that's tough and beautiful. You know, you can have something that's strong, but if a patient doesn't want to put it in their mouth and wear it because it's ugly, it's not going to do any good. And Trusana is that. Trusana has a good combination of all the things that you need to survive in the mouth and the oral cavity. And we'll kind of go through a lot of the advantages that the Trusana has. And like I always say, it's, you know, digitally designing cases is, you know, you aren't cutting your fingers and grinding your fingerprints off and dripping hot wax on your fingers and doing all that stuff. Digital is easier. It's not easier to do. It's easier to learn fast. Easier to learn faster. So what I mean by that is you still have to have the knowledge, you still have to have the experience, but somebody that you're training from a very raw position, right? They don't know very much. You can get them to a point way faster than you could the analog way, right? The traditional way. Traditional way, it could take, you know, a year, 2 years before somebody's kind of cut loose on their own. But during those 1 to 2 years, they're really not making leaps and strides. And it's hard to tell someone, I can't really pay you a lot until you know what you're doing and you actually can produce. With digital, you can actually get somebody to the point to where they're producing quickly. They will need overseen by somebody that has a lot of dental knowledge, you know, stopping points during the design to make sure they're going down the road that with the design that's proper and make fine adjustments, but they can actually produce. And so that's the exciting thing, because now, you know, we also, all of us used to, you know, put up with somebody who wasn't the nicest person or didn't work hard or whatever it might be, but because they were a good technician, we put up with it. Now we can kind of pick a good person, and that good person we can develop into a good technician much easier. So Trusana allows it to do that. All, you know, and because designing digitally is cleaner, it's a better working environment. You can train people faster. You know, I always say all I want is to be able to digitally design something and mill or print it, and it be as good, if not better, than what I can produce by hand setting up a case, hand waxing, investing, and injecting or packing a traditional acrylic. Traditional acrylic dentures, you know, have worked, and they worked for a long time. If I could get as good as that, I'd be happy. And you'll see here as we go through some of these results of some tests that were done, that we're as good in most of the categories, better in some of the categories, and very few, basically I would say just one were maybe just not quite as good yet. And we'll talk about that, and it's probably not as big a deal as a lot of people would think. So
Chris, I do have the results of the poll if you want to hear them.
sure.
So the first question was, are you 3D printing in your lab? And it's right down the middle. 50% are and 50% are not of who's listening with us today.
Cool.
And if they are 3D printing, we wanted to know basically what they were 3D printing. And it seems that most are printing models, splints, and guards, and about 50% are now printing dentures.
Okay.
So that's what we have.
Yeah, that's a really good mix. So yeah, I think everyone will be able to take something away from this presentation for sure. All right, so Trusana. So let's kind of talk about the development of Trusana. So Dr. Stansberry is the mastermind behind the chemistry and creating the Trusana as a material. And he was the one, as you can see, he's in dental, that saw the issues with all-in-X applications, and that was his initial thought process and application of this material that we now call Trusana. And Dr. Sadowski is kind of the boots on the ground type of guy. So he's the one working with it with patients day to day. And actually, me and Dr. Sadowski are working on some studies through some universities that essentially what we will do is, or what we have done is, the university will work with a patient, place an all-on-X case, right? So however many implants, most of them are 4 to 5 to 6 in that range. And they make your traditional metal substructure acrylic, pink acrylic with denture teeth appliance. Put it in the patient's mouth, adjust it over a few weeks. Any adjustments are done until the patient's comfortable. They then remove that from the mouth. They do a 100% 360 scan of that appliance. They then send me the models, articulator, and that digital file. I then print an exact duplicate of that appliance in the Trusana. And I do retrofit it using the model and the articulator with the metal interfaces. And that then goes to the school. They remove the acrylic and denture tooth initial version and then place the all Trusana version. And that would have, it is a monolithic, all tooth colored version. I would use OptiGlaze to color the tissue pink, so that we've really not changed, I mean, maybe microscopic amounts of the difference between the two appliances. And then that appliance is in the mouth for several months, even longer, depending on the patient's situation. And all failures, chips, wear, all of that is noted and kept track of. And so far, we've had one failure. That failure was a long cantilever, very long cantilever, but this is why we're doing these, is to find out where our limits are and set up our parameters on what can and cannot be allowed. And I don't know that I would have even done a zirconia case with that amount of cantilever. It actually stayed for about 3 months. It fractured right at the implant. We then redesigned it, removing the back molar, and that's been in now for probably another 4 or 5 months. So, so far so good on what was promised. We're getting nothing to what you see here. We're out of 191 prostheses, 34 of them had to have repairs and or remakes to them, and only over a short period of time, very short period of time. So here's a couple of the universities we've worked with so far. Some of these, Loma Linda has probably, I don't know, 6 or 7 of them that we're having the works. And so the very renowned university prosthodontic department in the universities. So yeah, we're I think Myerson, to their credit, they listen to what the chemists and the scientists tell them as far as strength is concerned. But until you make something that is a dental prosthesis and put it in the mouth, that's when you know that it has the proper strength to be in our industry in the mouth. And I think this is a good example of how Myerson's going above and beyond to hopefully gain your confidence with the material. And so one interesting thing about Trusana is it actually gets tougher when it gets in a higher moisture environment. And, I'm sure that has to do with the lubrication that comes with high moisture. One of the nice things about Trusana, you'll see in a slide in a little bit, is it absorbs very little moisture, almost as close to nothing as you can get. And a lot of other materials in the dental industry that are 3D printed absorb a lot of moisture. And when you absorb moisture, you take on stains, bacteria, and smells. And being able to resist the absorption and change its, things that take on moisture can tend to swell or not. I don't know that other materials do or don't, but Trusana remains, not only does it not lose any strength, but it actually gains a little strength as it gets in that high moisture environment. You can see we're three times stronger than PMMAs. And you can see down here, and it's not done, these tests aren't done by us, they're done by independent facilities. This is wear resistance. And that was the interesting thing. Jim contacted me, that's the owner of Myerson, I don't know, 4 or 5 years ago when this project kind of started. And he kind of asked me, he was like, well, right now we're having a hard time suspending nanoparticles in the Trusana. A lot of materials that are out there that you may have dealt with, in order to get some wear resistance, they will infuse the resin with nanoparticles. That's why some of them you really have to mix like crazy for like hours, is to really try to suspend those particles. And so early on, we thought we would need that. And, I kind of told Jim, I was like, wow, I mean, this material is so strong. And I was like, have you tested it like just itself, untouched? How's the wear resistance on it? And, he decided to test that, because my whole thought was like, look, even if you get close to what like a cheap denture tooth is, you're 3D printing and digitally designing, why don't you just make 3 dentures and make it a package deal, and then the patient can wear 1 a week, and then you get 3 times the longevity that you would with a denture made with cheap teeth. That was kind of my thinking back then. And then when he actually tested it, you can see here we got 2 times. That's not 2%. Well, that's 2 times the wear resistance compared to a premium denture tooth. All right, and you can kind of see how the cycles and again, this is done by an independent university. They did say that it was the best wearing plastic that they had ever tested, which is exciting. Okay, remember I said as good if not better. Right, so far we're in the better range, and this was really impressive. Right, so we have Kenson, which is an economy tooth. We have acrylic. Those guys are up in where acrylic should be, because essentially a economy tooth is acrylic. Phonaries, that's high-end denture tooth. You're looking at double the wear. Emax, this company had actually done tests on Emax, and we actually were much better than Emax. Now, it's apple and oranges, right? That's a lithium disilicate, but it's impressive. Now, the way that something wears on something else is by gaining friction upon that thing, right? You don't have to be necessarily a hard material, and you will just automatically wear on a less hard material. It's that the Trusana can come up to such a nice high shine and high polish. It doesn't absorb any moisture. It's basically porosity free. So it's such a dense material that whenever something rides upon it, it's slick and it slides over it. Now, don't get me wrong. It's definitely got hardness to it. It's been developed to be a hard material, to be wear resistant, but it's not as hard as Emax. So they're definitely different, but it's just really impressive, the wear resistance of that material. The flexural strength. So you have flexural strength, flexural modulus. One is the resistance something has to bending, right? So how rigid it is and how it'll resist bending. And then the other is how far will it bend before it breaks. And that's kind of that balancing act between those two is what you want for a denture tooth, right? You want it to be able to be hit, dropped on the floor, or a patient bite into something and hit a bone, or for our hunters out there, eat a bird or something that was shot with a shotgun and bite into a pellet. You want it to be able to take that and kind of flex and a little bit and absorb that, but you want it to be hard and rigid so that you have a nice strong biting surface. And so Trusana definitely has a good balance of those two. As I said, a lot of the 3D printed materials nowadays are can absorb a lot of moisture, up to 2%. Right, that's like more than our denture bases, and we have to store our methyl methacrylate, our packed and injected denture bases in liquids in order to kind of keep them saturated. Denture teeth, right, absorb about 0.4%. Right, and if you ever gotten a cruddy denture back for repair or just to be cleaned, you can usually get those teeth cleaned up pretty quickly by pumicing. The denture base can be a different story. It can be more of a challenge, and it's because the denture base they create gaps between the molecules in order to make it more shock absorbing. And but because of that, it does allow for the absorption of stains and stuff. Whereas the denture teeth don't really have to have necessarily that shock absorbing factor. And so they can make it way more dense. And they come out pretty clean. Well, the Trusana is 0.3. It's even less, it'll absorb even less moisture than the typical denture teeth that we use day to day. So when I talked earlier about its resistance to absorption of liquids, you know, it's remember I say as good, if not better. So far we've been better. So again, the materials are initially developed for all-on-X applications. And with that, typically you would do a monolithic appliance like, you know, I would do for those universities. Now, if it's going to be very, you know, somewhat short term, I would just paint OptiGlaze at the tissue area, because that's going to be the least amount of labor and it should last. I mean, it really would last probably years, but it is a surface stain. This case here that you see, this is actually the Gradia, all right? So it's still GC, but it's a stacked, basically a composite. So this tissue that you see on here, in most areas, is a few millimeters thick that's been layered on. And it bonds really nicely to the Trusana. And you can see the translucency that Trusana gives. And that's probably brings me to the one area where we may not be quite as good, right? So I would say that the aesthetics of Trusana is probably to the level of a economy to mid-range tooth. And the reason I say that is it's a monolithic. It's one material. Now the translucency of Trusana, as the incisal gets thinner, it allows more light. It naturally will show a gradient built in, but it's definitely not 9 layers like Myerson's high-end tooth, the Myerson specials, right? Now you can do some external staining, and I'll show you an example of that in a little bit to really accomplish some beautiful aesthetics, but that is a surface application. So that would be the one area where we're kind of either, maybe we're as good aesthetically in the tooth resin, but maybe not quite as good as a high-end, you know, 9-layered high-end quality tooth. This case here was done by Dr. Sadowski himself. This one was interesting. She had all of her uppers extracted. She then had a bar, some implants placed. We created a bar. From that bar, we actually used the denture base, right? The Trusana denture base and teeth, and then luted everything together, right? Because the bar rested upon the ridge. It was kind of a hygienic type of adaptation to the ridge, the pontic or the underside taglial surface of it. So we were able to bond everything together, and you can see really nice results. She's had that in for over a year, and her two son and daughter were both dentists. So talk about a little pressure on Dr. Sadowski, but everything went relatively smooth with that case. So what does that mean? Now, as it relates, I mean, everybody, when it comes to digitally design and 3D printing, it allows the opportunity to expand, to scale. We can teach our technicians faster. We can produce things, generally speaking, faster, and we can have consistent results. With All-on-X, this was an interesting case. So this is Jay Collins. He is owner of a lab, Cornerstone Dental Lab up in Philadelphia. It's a large lab, and he really has cornered a market in that area for temporization, All-on-X applications. So patient has implants placed and wants something that's not like a chairside conversion. It's more of, you know, they've gotten some healing done, they've taken an impression, and they want something that is screwed in and they can wear for an extended period of time until they're totally done healing or ready to move on to something more final. And so he uses rosin screws a lot. And rosin screw is a screw specifically designed so that you can create a plastic to metal interface. Um, you can look up rosin screw. There's a lot of nice information. There's a couple other competitors out there that create screws like that. But essentially, the screw head where you have like a ledge, and then down here would be the threads. We have that sharp angle which you see on most of the screws you work with. Well, rosin screw has a funnel to it, and so the head has a funnel. So as you screw it down in, it wedges itself. So it does two things. It spreads that pressure out of holding that appliance down, and because it wedges itself, it's able to create a lot more friction on the walls and is much better at staying tight and staying into place. So he used that a lot, and he was doing about 10 to 12 arches a day. And he had some VHF mills that he was optimized for plastics. But still, even if you optimize, depending on the size of the appliance, it could be anywhere from hour and 45 minutes to 2.5 hours to mill out one. And if you're not optimized, whether you have a VHF or anything else, that could be as long as 4.5 or 5 hours in the mill. But if you kind of take this, basically I traveled up there, did 2 trainings on 2 different days, and got them printing Trusana instead of milling. And you can kind of see, so 2 arches a day, that might be a little, he probably could get 4 or 5 done in each mill. So he was essentially take 2 mills that are 30, 40, $45,000 mills. So nearly $100,000 worth of mills were being taken up out of any other production just doing these appliances each day. Whereas with just the Asiga Pro, Asiga Max, which is the small build plate, you could stand up at a bit of a 20-degree angle and kind of inset them. And you could probably fit 4 on a build plate. Most of the time, unless you had a really big one, could cause a problem. But most of the time, you'd be able to fit 4. And that would print in 3, maybe if you had to stand one up a little bit, maybe 3.5 hours. And you'd have 4 done. And that's, a $10,000, $12,000 printer that can do basically what nearly $100,000 worth of milling machines was doing. And about $10 per arch is what the material cost is, where depending on where you get your pucks from, you could be anywhere from $40 for a puck for something inexpensive to, $80 or $100 for a puck for something that's high quality and has good wear resistance. And then, as if anyone out there is milling, the angles, the screw access angles, if they are a pretty counter angle to each other, the mill may not be able to reach that degree of undercut or path of insertion between the two. And you could have issues there. Whereas in 3D printing, it's not an issue. Most of the time, there's just no real undercut or anything that a 3D printer can't accomplish. And then, of course, if you had the Pro, the bigger build plate, you could fit bunches. You can see here there's 8 on the build plate, and there's a good bit of room in there. These could have been situated to even fit a lot more. So Trusana does come in a limited amount of 2 shades. We have a bleaching shade, which is 51. We have a B1, B2. We have A1, A2, A3. And we have pink. We have a light pink, an original pink, which is kind of your traditional pink. We have a reddish pink, a little bit more red in the name. And then we have a dark kind of ethnic or Mehari shade. So let's go over real quick kind of the process to, post kind of printing, but post-processing the Trusana. The first thing I want to talk about when it comes to cleaning, and this goes for whether you decide to try Trusana or you're making models or you're making splints, be very careful with how long the appliance spends in the alcohol. The alcohol is a very caustic material. It will break down plastic, especially since anything that you print with most printers comes off of the bill plate about 80% cured. And so it is in a weakened state until it's totally cured, the post curing. And so because of that, we have to be careful that we protect it up until that point. So what I recommend, or what the company recommends, is 2 minutes in a dirty bath. It can be dirty. I know some other companies out there want you to use fresh, clean alcohol. And it's because some of those other materials are very porous, and it'll actually pull the alcohol into it. And with the alcohol will come any of the dirty resin. So if you printed some models or whatever previously, it'll pull that in. And then now you have a foreign resin in a denture base, right? Don't have to worry about that with Trusana. But what you do have to worry about is breaking that material down by leaving it in there too long. So dirty alcohol, 2 minutes, remove it from there. What I like to do at that point is I'll lightly blow it with compressed air. Make sure you have gloves on, make sure you have eye protection, and make sure you have it in an area where I have like a box, and we replace the box every couple of weeks or depending. And it's almost like a little splash guard. I just hold it in the box and we spray, and it splatters onto the box, and that box kind of absorbs and allows it to evaporate easily. And then as you're blowing it, especially if you're doing an all-on-X case, you have screw access holes, make sure you blow in there. Let's force that any residual resin out. Let's force it thin so it's easily washed. And then I move it into my clean alcohol. I would like this last wash to be as close to perfectly clean as possible. Because again, you aren't going to absorb anything, but it will lay on the surface if it is some other material, especially if it's a material like a model resin that's not made to be in the mouth. Right now you're talking about cross contaminations of things. So have that nice and clean. You don't need a lot of it, just enough. If you have a mixer, just enough that it covers it. So being that you'll need to replace it fairly regularly, it won't be a lot of alcohol. And then put it in there for 30 seconds to a minute. I like to put it in for 30 seconds. I'll get my tweezers, I'll pull it out, and then I'll blow it with the compressed air. And you'll see when you blow it to compressed air, it'll evaporate that alcohol really quickly, and you'll see that the surface will kind of be dull. If you see any shiny areas or even some wicking as you blow, that will be residual resin. And in that case, you would want to put it back in for another 30 seconds and then blow it again. And as long as you don't see any wicking of liquid resin anywhere, you'll be clean. You can always use a squirt bottle to kind of squirt up into screw access holes or any areas, maybe the sockets of a denture base, to really flush anything out that could be kind of settling in there. That's perfectly okay. I wouldn't use a squirt bottle like a spray squirt bottle because it could really splash, but the little squeeze bottles with a little neck on them, those work really, really nice. Then if you're doing something and you don't have to bond any teeth at this point, you're just doing a monolithic case, you would put it in your Asiga flash, right? So you probably looked at that unit as something cheap when you got your Asiga printer and probably stuck it in a closet somewhere or a drawer. Well, pull it out because you'll be able to cure these resins with that, and it's validated and works perfectly fine. It might be a very simplistic light cure unit, but it works perfectly fine for this. So you'll place it for 12 minutes. You'll then flip it and then set a timer for another 12 minutes. Now, if you're going to OptiGlaze, if you're going to place Gradia, if you're going to be doing anything that's going to add more exposure to a curing light, adapt to that. What I mean by that is, so let's say that you're going to build some Gradia up and hit it with a little OptiGlaze to kind of do that. Well, as you build up pink and you build up even some tooth, you may be hitting it with a light, even if it's a little tabletop kind of tack light. You may be hitting it for 10 seconds here, 10 seconds there, 20 seconds here, 15 seconds there. You could rack up, the final cure, if you paint OptiGlaze, the glaze onto it, the clear sealant, that glaze is I think it's an minute and 30 seconds is the final kind of cure of that. So if you were, to have all those little tacks plus them, you could be as much as 3 or 4 minutes of extra light exposure. And keep in mind, OptiGlaze will not cure in your auto flash because your auto flash is 385 wavelength, whereas the OptiGlaze cures at 405 wavelength. So most of the curing units you probably have in your lab are 405. The auto flash is a 385. So if you do use OptiGlaze, you're going to have to cure it in a 405 wavelength curing unit. And that curing unit is a little bit more intense. So if you were to cure this for 12 minutes, flip it 12 minutes, then tack, expose it to light for another 3 or 4 minutes, and at a higher wavelength, you could actually raise the shade. You could actually discolor it, kind of burn it, overcook it. I don't know how you want to, you're overexposing it. And you could see it rise like a half of a shade or even a full shade if you were to really expose it. So what kind of this long diatribe is, let's do it at 10 and 10 or 8 and 8, depending on how much you plan to expose it to extra light and adjust to that. Something unique to the Trusana is it's 80 degrees, it has an 80 degrees Celsius water bath for 10 minutes. That's about 172 degrees, I believe it is, Fahrenheit. So if you have something in your lab that holds temperature around there consistently, that's fine, but it does need to be consistent. And this is an important part of the curing process. It is an annealing process and accounts for about 10% of the strengths that I showed you in a lot of those different graphs. So, I would recommend you go onto Amazon. A lot of different companies have these little electronic baths. They're made for like chemistry and stuff like that. And they're fairly inexpensive. And you can get them with like 1 beaker, 2 beakers, 4 beakers. And you'll just place it in a baggie. In there with the bag, you could put something heavy, just a piece of metal so that it pulls it down into the water, and leave it in there for 10 minutes. Once it's done, break it open. It may have a little bit of a darker shade to it at that point. It kind of accelerates things, but give it a little bit of time and you'll see that shade kind of simmer down back to being accurate. And then your case is cured and ready to have OptiGlaze placed or ready to be polished or whatever the situation be. Composite, as far as Gradia is concerned, is a pretty simple process. We talked about OptiGlaze. The kit of OptiGlaze comes with all kinds of different colors, anything that you could really imagine. If you have a Crown or Bridge tech that does your staining and glazing for, zirconia, they would really pick up on this pretty quickly. They'll love it too, because they don't have to put a little stain on and then run it up in a porcelain furnace for 10 or 15 minutes. They can literally paint a little stain on and just hold it in front of a light for 10 seconds and it'll tack it on. So they'll really be able to do some neat things with it. But really anybody could kind of catch on to this pretty quickly. If you're going to do Gradia and actually stack material for the pink, of course, with both, you're going to start out with a monolithic print. But either in the design or after the fact, you'd want to cut back that tissue area to make space. And then you can see Gradia has a lot of nice options. They have the more of like a composite or a putty type of an application. They also have some more flowable syringes that you can flow. I found that the flowable kind of syringes are good for putting a base on because it does kind of settle flat and have a little bit of very little character to it. So what I like to do is kind of flow on a base, kind of build up that way, tack that, and then I'll come back with the more puttied type feel, and I can build up rolls and ridges and just make it have a little bit more character. You can also contour, but I found once you get good at it, and it really doesn't take that long, the material handles so nice that you can pretty much have it contoured in the initial build. You really don't have to touch it that much. You can also, once you get a build, you can take the OptiGlaze and highlight things, give it little reds in the interproximal, little, kind of almond or white and blanch out at the necks of the teeth and kind of go, you can really do some amazing things with it for sure. And you can see you can really accomplish some beautiful look, but it is a surface stain. And it's a really resilient, becomes basically part of the material, but it is still just a, you know, surface stain. You can see the translucency. Again, I was kind of doing the as good, if not better, and kind of comparing like when you do a denture, and it's probably the best looking material that I've seen so far. When we first developed it and I got samples of it, the challenge was not trying to get translucency. It was that there was too much translucency in the material. And that's kind of the challenge out there. And you'll run into this with no matter what company you decide to go with for your digital dentures, is every company is trying to have this balancing act of having a vital looking translucent tooth but still meet the shade, right? And what I mean by that is shade tabs tend to have a decent amount of value to them, right? That's the brightness or the light that comes back to the eye. So if we make a tooth that matches the body of a shade guide perfectly, we would wind up having a tooth that looks like a chiclet, right? It would be just one stark, bright kind of color, but it would match the shade guide. Now, if we go more towards the translucent side of things, so we get some natural translucency happening towards the incisal and stuff, we're going to lower the value and therefore more light passes through, so it won't look as bright. So we do have shade guides for the Trusana that you can have to give to your doctors so that they can know what they're getting, and they can take a shade or pick a shade with the patient if the patient doesn't have any existing teeth. And I think that's a really good way of educating the doctors and letting them know that, you know, we have this is not a denture, carded denture tooth necessarily. And don't, you know, worry about buying equipment and machinery, maybe even software, and spending a lot of money and just to make dentures, right? You know, you can, as you can see here, this is a Duraflex milled base, and then these are Trusana teeth that I'll be fusing together. If you want to see a video on this, go to Myerson or Zahn's YouTube channel, and I did a two-part webinar that's pre-recorded and it's on there. It would have been back towards the end of last year. The first episode was probably in November or December, and then the second one was in like January, February, because they're all in chronological order. But I go over design. You can see there's little posts in there, and I talk about how to create those and why we're creating those. And then I talk about producing the teeth, you know, printing the teeth and bonding them together. So again, I guess my big thing here is you know, it's not all about dentures. There's a lot that you'll be able to accomplish digitally. Polishing, you can pumice it. It pumices about the same as you would an acrylic, maybe with just a little bit extra effort than compared to your traditional acrylic. We also have these brushes. These were sold by Myerson to go with our Duraflex and all of our flexible partials. Actually works pretty good on the Trusana as well. So, but you could traditionally polish. And you can see what I like to do is go over the surface with pumice to get any of the striations from printing out and any grinding that would have been done if you've done that. And then you could high shine it, or you could characterize it with the OptiGlaze, and you can kind of see, you can really add a nice, the Trusana is so translucent that it really allows for a lot of light to pass through. So when you do put a surface stain on there, it really absorbs that color and really becomes, doesn't look like you painted something on the surface when you're done. And so to kind of finish up, we'll kind of talk about the denture base. And, you know, we kind of went over Trusana. The denture base is the same chemistry as the tooth resin. It's just been manipulated formulated so that it's more impact resistant, right? So the teeth are formulated to be hard and wear resistant. The denture base has been formulated to be forgiving if it's been dropped. And so we have the tooth resin, we have the denture based resin, and we have our bonding agent. Now, I love this applicator. It's a super geeky thing. And when I received it, I thought that's kind of cool. But when I started using it, I was like, this is really cool. And so with that applicator, the cool thing is it's a little squeeze bottle. It has a little applicator tip. I'll show you the picture in a second. But it just allows for application of the material without really exposing it to unwanted light. You know, other materials have a jar, you unscrew the lid off. Well, the whole time that lid's been off, lights, you know, could be setting up that material. So, you know, being that it's a closed system doesn't allow for that to happen. And, you know, you'll print your denture base, right? This is the Sprint Ray. It is not validated for Sprint Ray yet. We're working on a lot of different machines to get it validated. Right now, it's validated with the Asiga, both the large and the small, Pro and Max. But as you can see, we're working on things. And with a larger build plate, you can fit a lot of dentures on there. Once you've printed, cleaned your base, follow the same instructions as we went over. Once you've printed and cleaned your teeth, following all the same instructions, do not cure. They're just printed and cleaned. At that point, you would do any adjustments. I'd recommend you need to wear gloves because there is some uncured resin involved in this process, whether it be the bonding agent or just the fact that the denture base and the teeth aren't fully cured yet. You do any adjustments to make sure the teeth fit flawlessly into place, and then you'll apply. And again, this is the little applicator, and you'll just squeeze and just put a thin coat of the resin into the sockets of the denture base. We recommend you kind of spread it around with a brush. I found the nozzle works pretty darn good to just kind of move that resin around, but you know, you'll kind of develop your own process as far as that's concerned. You'll then position the teeth, hold them into place. You should have some excess. If you don't, you'll wind up having some gaps. So you want to put enough resin that you will have some oozing around the necks of the teeth. You'll then take a brush. You can swipe at that and kind of wipe it on a paper towel and swipe it off, or you could just kind of spread it down from there if it's not a lot. It's essentially the same resin as the base is. So when you do your final cure, it'll just become one part of the whole thing. So just remove your excess, tack it. While you're holding everything in place in the perfect position, you'll just run around and tack. There's a lot of tack lights that you can find. Make sure it's a 405 wavelength. Most of them are. You can find them on Amazon. And you're literally going to hold it there for a few seconds, just enough to activate that and just hold everything and make sure you don't get any movement when you move it to your curing unit. Once you tack everything and you get everything that we want, you'll put it into your Asiga flash unit, and you'll go for your 12 minutes, flip it 12 minutes. You know, you don't have to have any special curing unit for this like some other systems. There's no more expense that you would need to have other than purchasing the bottles of resin and bonding agent and getting started. One cool thing here, when we go to the ISO certification, what they require to be considered high impact, we did 10 times that for our denture base. Now, I will tell you, the way it feels when I'm working on it and it, you know, my handpiece catches it and it flies across the room, or I'm polishing it and the lathe rips it out of my hands and throws it into the back of the lathe of the polishing unit, or when I grind on it with an aggressive burr or not, it feels very much like, you know, high-end denture-based resin. Right? I don't want to make any false promises that, you know, there's a lot of things going on with people doing extreme things to denture bases, and maybe if you tried it a couple of times, you could drive over it with an 18-wheeler or whatever's going on out there. Keep in mind, some other materials that you're seeing are very flexible, and the reason they're flexible is because they have gaps and spaces between the molecules. With Trusana, it's a 100% dense material, much better than any other denture base as far as packing or injecting the traditional way. And we're as strong, if not stronger, in most of my experience in real life, just working with the material. We're expecting, and I think it's true, a 60% increase. I think it'll probably be even more than that by the year 2025. I think for sure it's just moving so fast, so quickly, and the materials are getting so good, machinery is getting so good. I don't doubt that, and I wouldn't worry. I think this is true. I think some doctors, this is dental offices. I don't think doctors are going to be making their own dentures. I think some will, just like some did CEREC or E4D milling machines for zirconia. It's just messy. I don't care as much as you keep it clean. It just has a little bit of a mess, stickiness to it, and there is a technique to it. I think it's just going to climb, and I think the relationship that dental labs and dentists have as it relates to everything else will be similar with this. All right, and to end things, just a little peek behind the curtain of something that Myerson's in development of. There's many different types of printers. We've really dialed in to your typical, and there's iterations to them, but your batt and your build plate and your build layers. But there's also printers out there that work a lot like the printer in your office that prints your invoices and stuff, and it prints color and can print a picture. But can actually print 3D. And something Myerson's working on is the TrueJet, which is a polyjet or spray jet type printer that can print multiple colors. What this means is that you can print a denture base and a tooth color in one solid unit. And you could, in this printer, you can have around 3 units on a build plate, depending on the size, maybe more, maybe less. And those units could be, denture base. One of them could be A1, one of them could be A3, and it would print each one of them and print it as one solid unit. There's no bonding of the 2 units together. Here's kind of a little example how it works. It doesn't have support pins like you have with most printers. It has a waxy kind of support material that supports it as the thing's being built, and you can kind of see inside it creates the denture base and the teeth. And so it'll be fast. You should be able to print a build plate full of cases, which would probably be about 3 in an hour or so, depending on the kind of the height of it. And those should come out and need very little post processing, like you have with curing and bonding the teeth. So for high production and for having something that, what you create digitally will 100%, there's no risk of the teeth not quite sitting and now your bite's off. Some of the things we have to really take and be very careful of with the way we do it now really won't be as much of a concern. So that's something that's coming probably next year, but that's just a little kind of peek into that side of things and what's coming. Let's see if I can get past this slide. There we go. So with it, you can do about 24 arches a day, right? That's assuming you do 3 or so about every hour, depending on how many hours you can kind of do the math on actually how many you could produce. Here's the minds behind this. All guys that worked at Xerox, which sounds funny, but it's exactly their specialty. That technology is very much what they did. And so these are the guys all working on this project. We're real excited about it. And that's what the printer will look like. You have fewer hands, right? Fewer steps involved to having an end result. Training, as far as we talked about digitally, it'll be faster with this. It's very simplistic. You could have somebody trained a short period of time to kind of run that machine. You have, way more consistent, the efficiency comes from it all being 100% digital, and there's just less parts and pieces to piece together, and there's less possibility of a problem with your workflow. It does do multiple shades. There's even a possibility in the future we might even be able to do a gradient built into the tooth. That's not something that'll probably be with it when next year, but it's something to look to in the future with this type of technology. And so all these materials that will be used in this machine will be Trusana. So all the characteristics we talked about through the presentation, you aren't going to give up any of that strength for producing them this way.